We finished. So now
Yes.
let us do some questions on electric field, right? Let us first understand what are the concepts involved with electric field, right? So we have here. So we have a point charge, right?
Hmm.
And if we calculate the electric field at certain distance, let's say R, at this point, so what is the electric field? That is,
KQ by.
yeah, R square and simply R, right?
Hmm.
So that is simply F by whatever charge was there, right? So let's say whatever this test charge was there, let's say Q1. So this is F by, let's say, test charge Q, right? Where this Q is a test charge. So this Q is a test charge. This is a source charge, right?
Hmm.
This is providing the electric. Okay, now the second point is that, so this is electric field due to point charge. If we have multiple charge, right? So if we have multiple charge, then what is the electric field? So let's say we have Q1, Q2, Q3, Q4, and so on up to Qn. We are calculating the electric field at this point. So this would have some distance, let's say R1, this will have some distance R2, some distance and some distance. So this electric field would be the superposition of all those other electric field, right?
Hmm.
So this would be simply how much? So we calculate the individual electric field, and this would be simply KQ1 by R1 hat, and then square, so this should be square, and then KQ2 divided by R2 square and R2 hat, and so on, right? So KQN divided by R square, R1 hat bench. So this is where the electric field due to multiple charges, right? Okay, and then we calculate the electric field due to the dipole, right? So electric field due to dipole. But before we understand electric field due to dipole, first let us understand what is dipole. So dipole has two charges, equal charges, separated at a very small distance, right? So let's say this
Hmm.
is 2A. The separation is 2A. This is minus Q, this is Q. So there would be a dipole moment in this direction. And that we will call as P. So how much is, what is the magnitude of this P? This is
Q
P,
into 2A.
yeah. So the magnitude of this P is simply charge into the separation. So separation is 2, right? So 2A. This is uh, this is the dipole. And what is the direction? Direction is from negative Q to positive, always, right? So now what is the electric field due to that, right? So we have this electric dipole. This is minus Q, this is Q. So this would be the direction of dipole. So there would be two choices of the points. One would be that this perpendicular, right? And the other would be this line, right? So we are calculating at, let's say, P point and let's say at Q point. So this point, P would be called the axial point, and this point is what we call the equatorial. So if we calculate the electric field at this point, EP, I will write the magnitude or the vector as well. So EP is minus 2 kq, or not minus 2 kq, but this is simply 2 kq or 2 kp, 2 k by r, right? So this is the electric field of the dipole due to axial, at axial, right? Do you remember this thing?
Yes, sir.
And then what is the electric field at equatorial point?
Mm,
This is minus Kp by R2, right?
yes.
This is equatorial. And if you want the derivation at any point, you can also tell me that, but yeah, just remember this thing, right? And what is the behavior that we are seeing? So we see that this axial point is 2 times in the magnitude, if you talk about the magnitude, right? So EP is 2 EQ, right?
Yes.
Right. If I multiply 2 in here, so this would be EP, right? Oh, so yeah. Now, and the direction is where? So direction of EP or direction of EQ is opposite to direction of EP. Right. So we see that the direction of the EP point, axial point, is in the same direction of the dipole moment. So same as this one, right? This is the direction of P. So electric field would be at this direction. Give me one moment. There is a problem. Yeah, sorry about that. So yeah, so we see that whatever the direction of the dipole moment, so the electric field at any axial point, that would be in the same direction as this point, right? Similarly, if we calculate the electric field at the equatorial point, let's say here. So what is the direction of the electric field at this point? We have minus P direction. So that would be in this left direction, right? So
Okay.
these are the points that we have to remember. That axial point will have same direction, equatorial point will have opposite direction. Okay. So if you calculate electric field at here, this would be in this direction at this point, in this direction, this point at this direction. But if we are at the axial point in here, somewhere here, so that would be in this direction. Clear?
Okay, sir.
And how do we calculate the direction? That is also, how do we calculate the distance? What is this R? That is also important. So we have this middle point, right? And from
Yes.
this middle point, we calculate this distance. What happened? Yeah. So whenever we calculate the distance of the dipole, so we calculate. Okay, now this will not be erased, right? Yeah. Okay, so yeah, so what I was writing,
The distance.
yeah, the distance. So the distance would be from this center, right? So let's say this would be R. There are lots of lines, but yeah, this won't be erasing because this
You
notepad
can
has.
do it with another color.
Yeah, oh, good. Yes, great idea. So this would be the distance of R, right? So we always calculate the distance, and similarly, the R would be from here to here, right? So if we calculate if we calculate the distance for the equatorial point, so we calculate from center. If we calculate the distance from the axial point, so again we calculate it from the center. Let me just draw it in here also. So let's say this is the center point, right? This is minus Q, this is Q. This would be A, this would be A. And yeah, I'm calculating the electric field at this point. So I will be taking the distance from here. That would be my. Similarly, if I'm calculating the distance, I'm calculating the electric field at this point, equatorial point. So this would be my. Right, clear? Okay, so these are the things that we have to remember in this electric field calculation. Please note these things down and then we'll do the next. Then we'll do the numericals, right?
Okay.
Yeah, whenever you want me to scroll down the screen, please take.
So can you scroll down?
Yeah.
Yes, I wrote it.
Yeah, so now let us do some questions and then this would be so whenever you get electric field kinds of questions, so we have to use only these are formulas, right? So let me just bring for questions that we are going to do, right? Yeah, there will be lots of questions, but we will be doing selected questions, right? So only the NCRT ones. So electric field due to point charge and superposition principle that we have learned. So now let us do some questions by using those idea, right? So the let us start with the simplest questions, right? So 2 point charges of 2 and are 1 centimeter apart. What is the magnitude of field produced by either charges at the side of the other? Right. Standard value of 1 by 4 pi epsilon naught. Okay, so that is not given, but what is that is 9 into 10 to the power 9, right?
Hmm.
So we have two charges, right? Let's say this is Q1 and Q2, right?
Yes.
We have to calculate what is the magnitude of field produced by, let's say, field produced by Q1, right? So this field would be produced by Q1, but where we are calculating that thing? We
On
are
Q2.
on Q2. Absolutely correct. So we are calculating at this point. So we are calculating E of Q1 at point Q. So this is, let's say, let's name this point, right? So A and B. So we are calculating at B. So this would be simply K Q1 divided by whatever this distance AB square, right? And similarly, if we calculate electric field of Q2 at A point, we have to calculate, right? So we're calculating due to this charge, this is the source charge, and we are calculating it at this point. So this would be simply KQ2. Again, that would be AB square, right? Okay, so we have all the values, right? So we can find out. You calculate and tell me what would be the correct option, right? So, and then we can check the answer. Please calculate, then you will practice, yeah. Then you will be able to practice. Yeah, whenever you get any answer, please tell.
So is it C?
C. Okay, so let us check that. Right. So 9 into 10 to the power 9. Q1 is, let's say this is 2, right? Into 10 to the power minus 7 divided by 1 centimeter. So this is not in SI units, right?
Yeah.
So 1 into 10 to the power minus 2 and then square of it, right?
Hmm.
So 9 into 10 to the power 9, 2 into 10 to the power minus 7, and then 10 to the power minus 4. This will go upstairs, right? 9 twos are 18, and then 10 to the power 9 minus 7 plus 4. So this would be how much? 18 into 2 plus 4, that is 10 to the power 6, right?
Hmm.
And if you're writing
So
it into, yeah, so
is
this
it
is,
not
yeah, so
10
if we
raised
write,
to 5?
yes, yes, so
Okay,
this
no.
is, yeah, this is 18. So if we
Yeah.
write it in 1.8, then this will be 10 to the power, right?
Mhm.
And that would be Newton per Coulomb, right? Force by charge. So yes, you are absolutely correct. Good. Okay, now this question was simply using the idea of electric field due to a point charge, right?
Hmm.
Good. So that thing we have already calculated. So you just have you noted down the question because the calculation you have done on your own, right? So that you don't.
I
Did you
will
note
write
down?
it down.
Yeah, please write the question because what is the answer that you are writing and what was the question? If you don't have the question, then you won't understand the answer, right?
Yeah.
Yeah, so just note down the question. Whenever you have noted, please tell.
Okay. Sir, I'm done.
So now let us do the next question, right? Next question involves, again, the previous question involved two charges, but in the next question, we have also two charges, right? They are 8 centimeter apart. Now we have to determine the position of the point at which the resultant field is 0, right?
Hmm.
So let us draw this diagram first, and then it would be clear to understand, or it would be easy to understand, right? So we have two charges, 16 microcoulomb, and then the other one is minus 9 microcoulomb, right? And the separation between them is 18 centimeter or 8 centimeter. So we have to find out, right? We have to find out the position of the point at which the electric field is 0, right? Does this question remind you of any other ideas that we have done at some stages?
Mm,
Yes.
don't know, sir.
Okay, so you see that what about the equilibrium condition?
Oh.
Yeah. So this is
Hmm.
something like that. So what we are doing is that we are calculating, let's say we pick this point, right?
Both the electric field should be equal to each other.
Absolutely correct. Good. So, yeah. So let's say that we say this is some x distance, right?
Hmm.
So what would be this distance?
Yeah, 8 minus x.
8 minus x. Absolutely correct, right? And this is the point at which we are calculating the electric field. Let's say this is A, this is B, this is P, right?
Hmm.
Now, if you look at, yeah, so if you look at the contribution from this part, so that would be in this direction, right?
Hmm.
And if you calculate the contribution from this part, so this would be, what would be the direction?
It'll be left side.
It would be, is it repulsive or attractive? You can think it like that.
Subtractive.
It's attractive. So that would be again in at this point, right?
Oh, okay.
So which means that we can't have a point in between these 2 points, right? In between these
Hmm.
two A and B. So we discard this scenario, right? Because we can't have the point in which we can have the electric field zero, right? So that should not be in between A. So we can take the, yeah, so we can take the point at this side, right? Let's say we take the point at this side. And this is X. So at this point, this would be, due to this one, the electric field would be in this direction, right?
Hmm.
And, oh, okay. Okay, so if we look at the option, right?
Hmm.
Okay, in whatever way we want to do this question, we can do this question. But yeah, so yeah, we'll do that. So let's say that due to this one, this is in this side, and due to this one, what would be the direction?
The right side.
The right side. Absolutely correct. So this would be E. And this, when this would be equal, then the resultant would be zero. So when EA and EB are equal, then resultant is E net, right? That would be zero. So let's put EA equal to EB. So if I have taken this as X, this is 8 centimeter, right? So we are calculating the answer in centimeter. That we have to keep in mind, right?
Hmm.
Okay, so what would be EA? Can you tell me? What would be EA?
8 plus x. Hmm.
No,
Okay,
we
now
are
you're talking.
electric field.
E,
Yeah.
it'll be kq by x square.
Yeah. So what is okay? K and Q is 16
16.
microcoulomb, and then X square, right? So good. And what would be this thing? KEB?
EB will be k into minus 9
No.
microcoulomb.
See, when we have taken the direction, right? When we have taken the direction, so we
So,
have already incorporated this nine negative thing, right?
hmm,
So then we are overdoing it. So then we just write this, right? And this is what would be
8
in the
plus x
good.
squared.
Yes. Good. This is so K cancels, microcoulomb cancels. 9 and 16 we cannot cancel, right? Good. So let's take this thing. So 16, 8 plus x whole square, that would be equal to 9x square, right?
Hmm.
So how should we solve this question? How should we solve this question? Okay, you see that in every term there is a perfect square, right?
Yeah.
So taking square, right? If we start to solve this thing, then it will be troublesome, right? So we just take the
Hmm.
square. So we take the square root. This would be 4, 8 plus x, right? And then this would be how much?
3.
Plus minus 3x, right?
Yes.
Because whenever we are taking the square roots, it will have two solutions, right? So if we take 4 plus 3x, we will have, what would be this thing? So this would be 32 plus 4x and equals to 3x. So this goes in the other side, this becomes 32, this becomes 3x minus 4x. So that is x equals to minus 30 centimeter, right?
Hmm.
And the other direction that would be, so the other direction can be, because x is negative, so then we can discard this thing. So for x equal to minus or for minus 3x, right?
Yes.
So this would be 4, 8 plus x equals to minus 3x, right? So this is 4, 8 32, and then this is 4x, and then this is minus 3x, right? Okay, so again we are getting, yeah, so this is 32, and then this is 7x or minus 7x, right? So this is minus 7x. So x would be how much? 32 by 7 and minus. Right, so these are the two solutions, right?
Yes.
But yeah, you see that in the option, so this is minus 32, which means that we are not going left. We are
Hmm.
not going left. X equals to minus 32 means that we are going right, right? So we are calculating this, this is minus 32, right? So this is somewhere here. This is point P, and that is 32, right?
Hmm.
So from here to here, that is 8. So B to P, BP would be how much? 24, right?
Yes.
So if we calculate, we are measuring the distance from where? From where we are measuring the distance?
B and P.
We are measuring the distance from 9 coulomb charge, right?
Yeah.
So from 9 coulomb charge, we have to go 24 centimeter right. Clear?
Yes.
So this would be the correct option. Clear?
Yes, sir.
And there are also the fractional ones. So this is also right, but this is not there in the option. So this we can discard, right? Okay, so, so yeah. Is this thing clear to you?
Yes, sir.
Okay, then please note this thing down, right?
Okay.
So you understood this part, right? Because what I was telling you that
Hmm.
we can take the starting from point from here, or we can take the starting point from here as well. So let's say I draw like this. Right, I draw it like this. And then I choose this point to be in here. Right, so let's say I take
Hmm.
this point to be in here. So this would be x, right? And then I measure all these distances. Okay.
Okay.
Yeah, so we'll check this scenario as well. So, but before we do that, let us quickly, yeah, you just note down the question first and then note down the answer. First, note down this question. And then we'll see that because in the option, they were talking about this 9 coulomb charge only. So we
Hmm.
will measure the x in this scenario, right? But yeah, this is also correct. No So there's no incorrectness in this. Note down the question and then answer.
Okay, sir. Yes, sir.
Okay, noted down this part.
I did that. I wrote.
Okay, and then you noted down that why this should be 24 centimeter, right?
I did that too.
Good. So now let us understand this with this picture, right?
Hmm.
Both are correct, right? Whatever method we choose, both are correct. But yeah, so looking at the option, we can or we should start with, we should take the direction with -9 Q charge, right? So that should be the correct. Both are correct, but more appropriate way should be that using this distance, right? So now we have this point. We take this point, right? Due to -9 coulomb, the electric field would be this direction, EA. Due to this one, the electric field would be in this direction, E. Right? This is 8. This is X. So if we write EA, I'm directly writing, right? Just to show you that from both the ideas, we'll get the same. So EA is K 9 microcoulomb divided by X square, right? And this
Hmm.
would be K 16 microcoulomb divided by 8 plus X square. So microcoulomb cancel, K cancel, and again we have 9, 8 plus X whole square, and this is X square, 16X square. Right. So this would be 3, 8 plus x, and this is plus minus 4x. Right. So this would be 24 and plus 3x equals to plus minus 4x. Right. So
Hmm.
we can have x would be, or we can take positive this thing, right? So for positive 4x, this would be 24 plus 3x equals to 4x. Right. So this would be how much? So this is 24 and this is x. Okay. So, and then if we take for minus 4x, this would be 24 plus 3x minus 4x. So that would be 24 and then minus 4x plus minus 4x and minus 3x. So again 24 and minus 7. So this is, yeah, so this is how much x is minus 24 by 7, right?
Hmm.
Okay, so now we get directly the answer, right? That this x should be how much? That should be 24, right? So this is 24 at
And from 16 microcoulomb charge, the distance will be 32 centimeter.
yeah, so from 16 that would be 32 centimeter, but there we have a problem of right and left, right? In
Hmm.
here, in here, if we choose this thing, in here, if we choose this thing, so that would be left, right?
Hmm.
So yeah, there should be, yeah, because if we change the position of these two things, so right and left will change, right?
Okay.
If I write 9 coulomb in here, so left would be this thing and right would be this thing, right?
Hmm.
So there should be a correct way to, okay. So what we can do in this scenario? If we have a right and left problem, then what we should do? Please, then yeah, so this is dependent upon the position of this 9 and 16 that you take. If you
Hmm.
take, if you take, let's say, if you take that this is 16 and this is minus 9, and you start the distance from here. Let's say you put x equals to here, right? You put x equals to here, and then you calculate the direction from the right hand side, right?
Hmm.
Then what will happen? So then you have, because this is x, so again you calculate from this point, right?
Hmm.
So at this point, again, you have this A and this B. So this EP, this would be EA, and this would be EB, right? Again, what would be this thing? So if we calculate from here, so EA is equal to EB. And there is a problem of right and left, right?
Hmm.
So, so how do we solve that thing? So this is K and Q. Q is 9 microcoulomb divided by x squared. And then this is K and 16 microcoulomb divided by this 8 plus x whole square, right? So this K will cancel, microcoulomb cancel. This becomes 9, 8 plus x whole square. This becomes 16x squared, right? So this becomes again 3, 8 plus x and plus minus 4x. So if we take for plus 4x, right? For plus 4x, where are we getting this thing? So this is 24 plus 3x and plus 4x. So now what you are seeing? What you are seeing?
20.
24. We are getting the same answer, but where are we? What is the direction? This X
The
is where?
direction is left.
Direction is right, right?
Yeah, right.
So this is 24 centimeter, right? But if we place this thing, if we take this scenario, right? If we take this 9 coulomb in left direction, so the answer would be 24 centimeter, but what would be the answer?
In the right direction.
Left,
In the
left,
left direction. Yeah.
right. So then this should be, so then there are two options which are correct. Both are correct depending upon what?
The point that we take.
Yeah, depending upon where we fix this 9, -9.
Yeah.
If we fix this in left hand side, so that would be left hand side. If we fix right hand side, so that would be right. Clear? Is it clear?
Yes, sir.
Okay, yeah, no need to note it down, just to, yeah, so in the, they have said, you see that they are getting 2D, but this C option is also true, right?
Hmm.
So if we place this thing in this direction, then your answer will change. Okay, so yeah, magnitude will not change, but right and left will change, right? Okay, so now let us move on to the next question. Okay, so the next question is that ABCD is a square of side 5 meter. Right, so let us make this ABCD square. Of side 5 meter. Right, this is A, B, C, D. Right. Charges of 50 coulomb, right? So charge of 50 coulomb is placed at this point. Charge of -50 at C. And +50 at D. Right.
Hmm.
Find the resultant electric field at B. Right. So we want to find out the electric field at B. Right.
Yes.
So now if we write this thing, if we write this thing in vectorial representation, this becomes very easy to solve. Right.
Hmm.
So ultimately what we have to find out that EB vector, that would be contribution from A, contribution from C, contribution from D. Right? Am I correct? Superposition principle.
Yes.
So I have to, let's say that due to this one, due to C, the electric field, what would be the direction of the electric field?
It'll be downwards.
It would be downwards, right? Absolutely correct. This is so. Let us write, and if you think about the magnitude, right? If you think about, okay, we'll talk about magnitude later. So let us write. Let us write. This is EC, right? So let us write EC vector. EC vector would be K, right? And Q is 50. Because we have taken the direction, that is why I'm not writing this mind, right? So always remember this.
Hmm.
50 by 5 square, and direction is how, what is the direction?
Downwards.
So what in vector form, what is this direction? What is this direction in vector form?
I forgot.
Yeah, they are orthogonal. So this is x, y, minus x, minus y, right? So what is this direction?
Minus y.
Minus y is not a direction, right? How do we write to what? So did I not switch on this thing? Give me one moment. I have to switch on the. Okay, so I forgot to switch on now. Yeah, so what is this direction in vector form? Y is not a direction, right?
Hmm.
What is the direction? That we talked about in vector classes, right? So minus j hai.
Oh, okay.
Yeah, right.
Yes.
Because if we write any
Hmm.
vector would be magnitude, magnitude we calculated, direction is minus, right?
Yeah.
So this would be, let's keep this k because this would be common. So this is k, this is 50 and this is 25. So this is 2 and minus j. So this would be minus 2k j, right? This is
Hmm.
easy. Let us write this a because this would be easy. So due to a, what would be the direction of the electric field at b?
It'll be right side.
Right side. Absolutely correct. So this is our a. Let us write E. Again, the magnitude would be same. And direction would be what? What would be the direction?
I cap.
I cap. Good. So let's write it as 2ki. Right.
Hmm.
But there is a catch in this one, right? So we have to calculate the contribution from D. So that direction would be this direction, right? Along the line of, this is the line. So this would be in this direction, right?
Yeah.
But we know, right? But we know that this angle is 45 degree, right?
Hmm.
So we have a 45-degree angle and we have a magnitude, right? We have a magnitude and magnitude is how much? So this is 5, this is 5. So this would be root of, or that would be 5 root 2, right? This BD distance. Clear?
Yes.
So if we write, let us, before we write this ED, let us write the magnitude of ED. This is the magnitude of ED. So magnitude of ED is K and 50 divided by 5 root 2 whole square. So this is K 50 divided by this 5 is 25 and then 2. So this is simply K, right?
Hmm.
Now, if we write this in IJK form, so we have to remember the resolution of vector. So how do we do that? We have ED, right? This is 45 degree. So this would be ED cos 45.
Yeah, cos 45.
This is ED sine 45, right?
Hmm.
ED is K. So if I write ED vector, so this would be K cos 45 I hat plus K sine 45 J hat. Am I correct or incorrect?
It's correct.
Yeah. So then I have this ED vector as well, right?
Hmm.
So let us write this thing. So ED would be K by root 2 because cos 45 is 1 by root 2. This is also 1 by root 2 J hat. So this is my ED vector. Now I have ED, I have EA, I have EC. So then I can write the value of all these things, right? So then I can write that what is EB? EB is simply EA, EC, and ED. So EA was 2K I hat. EC was how much? Minus 2K J hat. And this is K by root 2 I hat. And then this is K by root 2 J, right? So what is the answer that they are? Okay, so we have some magnitude, right? Good. Then what we can do? So then this is simply 2K and plus K by root 2, right? I hat. And this is K by root 2 minus 2K and then J hat. Correct.
Yes.
What would be the magnitude then?
You'll have to square them.
Yes. So this magnitude would be square of this and this thing. So I can write this as 2K minus K by root 2 square. Right. Why I can write this thing? Because A minus B whole square, that would be equal to B minus A whole square. Am I correct?
Yeah.
Now, if we identify this thing, so this is A plus B whole square plus A minus B whole square. So what you will get?
A square minus B square.
No. So this would be A square plus B square plus 2AB plus A
Oh.
square minus 2AB plus B square. This will cancel and you will get 2A square plus 2B square, right?
Hmm.
So let us write that thing directly. So this would be 2A is 2K square, right?
Hmm.
And B is K by root, right? So K by root 2 whole square. So how much is this thing? So this is, and then this is 4K
Four.
and this is 2K square by 2. This will cancel. So this is 8K square plus K square. So 9K square. So this is simply 3K, right?
Hmm.
This is the magnitude of this thing. So 3 into 9 into 10 to the power 9. So 27 into 10 to the power 9. So 2.7 into 10 to the power how much?
10.
Yeah. So 10 Newton per meter. Which one is the correct answer? 2.70, right? So this is the correct. Is this thing clear to you?
It's clear.
Good. So please note down the question as well as the answer. So please note down.
Okay. So can you scroll right? The answer.
Yeah. So you see that why vectors are important, right? You have to remember resolution of vectors. You have to remember the IJK Cartesian form. So yeah.
Hmm. So can you please scroll down?
Yes, yes. Yes, whenever you have noted, please.
Yes, sir.
Yeah, whenever you have noted that, please take. Whenever you want to scroll down the screen.
Yes, sir. Can you scroll down? Yes, sir. A little bit down.
Done. Okay, so now we have a similar question, right?
Hmm.
We have a similar question, but the values are not given, right? So they are given in terms of the alphabetical letters, right? So in this question, we were given the values of the charges and all those distances, right? So in the next question, those things are not given, but the idea would be same. Right, so idea would be same. So okay, so let me just erase this thing.
Hmm.
So the next question is similar, right? And there could be, I guess, there is some misprint in this question. So this should be comma, right? This is not Q1. All these are Qs, right?
Okay.
So you have plus Q, Q, again plus Q, minus, right? Are placed at the four corners of ABCD, right? So let me just draw this thing and then you practice. Because this question would be very, so if you solve this question, then you'll get, yeah, more confidence, right? So,
Okay.
yeah, so you have a square, right? And yeah, so this is plus Q, let's say this is A, this is B, this is C, this is D. So you have plus Q in here, right? You have at B plus Q. You have minus Q at C, minus Q at this. And the square of side A. So you see that all these are alphabets, no numbers, right? Now they are asking that calculate the electric field at the center of the square, right? So you have to calculate the electric field at the center of this square. So to calculate the electric field at the center, we need the separation. Let's say this is O, right? So what we will do is that this time we will not write in the IJK form, right? So this time we will not write that because it will take some time. Right, that would be again easy, but it will take some time. So what we can do is that we know that this diagonal would be how much? This diagonal would be how much? This is A, so that would be root 2A, right?
Yeah.
And I can write root 2A as 2 by root 2, or let's write this thing, right? So this is root 2, right? So if I want the distance between these 2 points at halfway distance, so this would be root 2A by 2, right?
Yes.
This would be again root 2A by 2. This would be root 2A by 2. This would be root 2A by 2. Again, is this thing clear?
Yes, sir.
So now if I'm calculating the contribution from A, right? So what would be the direction? At this point, I'm calculating. So the direction would be this side, right?
Yeah.
This is EA. And remember, what is this angle? This is 90 degree, right? So that is
Yeah.
why I'm not writing the ijk form, right? Because these are not in the x and y axis. So we have to resolve all those vectors. So that would be troubles, right? So let us write only this EA. Okay. And this is the direction of EA. If I talk about contribution from C, so that would be, what would be the direction of that?
It will be this upwards from there.
Upwards. This is, remember, minus. Minus, right?
Yeah,
So that would be attractive, right?
yeah,
So the same direction as here. Clear?
okay.
Now let us write the contribution from B. So contribution from B would be where? BD or DB? What would be the direction?
BD, from
BD,
B to
right?
D.
So absolutely. So this would be the direction. Now, if I calculate the contribution from D, what would be the direction?
The same BD.
Absolutely correct. So this is D. So you see that both are in the same direction. So whenever you have two vectors, they are in the same direction. So let's say 2i and 3i. They are in the same direction. So the net resultant would be 5i, right?
Yes.
So EOC would be, if I'm calculating E net, so that would be EOC, not right now. Let us only calculate EOC, right?
Hmm.
So that would be, I'm only writing the magnitude. So that magnitude would be simply EA plus EC, right?
Yeah.
Okay, and what I can talk about, or what can I tell about the magnitudes of EA and EC? So I know that for every charge magnitude is same, distance is also same. So EA would be equal to EB, that would be equal to EC, that would be equal to ED. Is this point clear to you?
Yes.
So I can write that as E, right?
Hmm.
Let me write it so let's say that this is E, and I can write this E magnitude. Let's write it as E and plus E. So that is 2E. Similarly, what I can say about EOD? That would be also EB plus E, right?
Yes.
So again, that would be 2E, right?
Hmm.
Now I have two vectors, they are perpendicular. So what would be the what would be the net electric field or net resultant? So that would be the parallelogram law, right? So I make this
Hmm.
diagram in here, this diagram in here. So this would be my net, right? This is E net, right? And
Yes.
magnitude of E net, that would be, because the vectors are perpendicular, so that would be EOC square plus EOD square. Right, so this is 2E square plus 2E square. So that is 4E square plus 4E square. So 8E square. So this would be 2 root 2E, right? And I already know that what would be this E. So let me write this E at this. Oh, I have done this thing all together. So this was supposed to be. So this is K, Q, and separation is root 2A by 2 whole square. So this would be KQ, and this would be 2A square. This 2 will go upstairs. So this would be 2. So this is simply 2KQ by A, right?
Hmm.
So I can put this value in here. So this would be 2 root 2 and kq, 2kq by a square. So this is 4 root 2 kq by a square. That would be the answer, right?
Okay.
And what is the options do we have? So 4kq by 2c. 4c. Clear?
Okay, sir.
So note down the question and practice this question on your own as well, right? Practice this question
Yes.
on your own. So that will give you a confidence in your calculation. So whenever you have noted the question, please take.
Okay.
Mariam is not taking these classes, right? These are very important. And these are the things that come in the exams, right? So derivations are there, obviously, but these are the
Yes.
main type of questions that come, right?
Hmm.
Yeah. So whenever if you feel that the derivation of dipoles, they are not clear, so just tell me. Then I will derive those things, right?
Okay, sir. So can you scroll right?
Right. What I will tell you that you just have you noted down this diagram.
Yeah, I did the diagram.
Then you practice this question on your own, right?
Okay.
So then if you don't get the answer, then we'll talk about this. But yeah, you just practice this question. Please. I guess, oh, Mariam. Okay, so was that the same Mariam that is taking our class today? I
I
guess,
did see.
no, I guess she is